Eclectic, bringing you our next in a series of presentations, being guided by the number 2. That's our rubric, which is a very good word to know. The number 2 repeatedly appears at the foundational level of cutting-edge physics. You can think of several examples of these dualities, as they're often called appropriately so. Electromagnetism itself is a compound word of two basic words, which amount to electroforce and magnetoforce. What we're going to be looking at today is a continuation of our prior presentation, an introduction to the Boschkovich force curve, which you see here. Roger's work followed up on that of Newton and Leibniz. So I just wanted you to see this curve. Don't worry about all the lettering. The series of curves, and there's one, and there's the second one, marked K at the bottom, and then there's the innermost curve, which goes down below the median line, the horizontal line, and then rises on its last upward arc, and then is cut off at the top of the diagram. So without any further comment on that, I want you to see some other images. This shows essentially what we're talking about when we talk about the nucleus. And even though this looks just a little bit, I don't know if you really notice anything instructive about this, but I like it because it's so simple. And in the center, you'll see the light blue and dark green represent protons and neutrons. Now, essentially, you can eliminate from this picture everything in the center except for one proton, and then everything else still makes the same amount of sense, which is just two labels. A series of arrows pointing in, labeled attractive, strong, nuclear force. The proton is always at the center of the atomic system. One proton, that would be hydrogen, of course 99.9% of the universe is made of hydrogen. The center of an atom can be as simple as just one proton, and that's all we're going to be talking about. And that's quite typical. It's not a contrivance to simplify it. In other words, that's not oversimplification. So you can forget about the neutrons, except to realize that they can exist in what are called isotopes of elements. And you can also disregard the presence of the other protons, because they're there just to show that there's 1 to 100, approximately there are 100 elements that are stable. And you can look that up to find out how I'm not exactly right about that, but it's a ballpark figure. There are approximately 100 elements. So there can be as many as 100 protons in one center of an atom, in which case it would be that element that has 100. If it's 92, it's uranium, so that, if you didn't know that, now you know. So we have one proton sitting there in the middle with possibly other protons and possibly other neutrons, which we don't care about. We only care about one proton. And so the main thrust of this really simple diagram, I think, is that there are two forces. There's the attractive force, and there's the repulsive force. So it's a spherical, repulsive force field. Those arrows indicate a field. So it's a repulsive force field, which has the additional adjective electromagnetic. It's electromagnetic repulsive force. It indicates a force field that's pushing out. You might ask, against what? We're getting to that. The 4 arrows pointing in, you recognize instantly as gravity. That is gravity. Of course it's not. You know, I'm pulling your leg. But remember that I said that. Because if that really is gravity, and it can be proved that that's identical with gravity, that would be the unified field solution. So I would be going out on a limb, and I took a chance to just pull your leg there a little. That's not gravity, that's attractive force. Now, that force would also be a force field, since it's simply the inverse of the repulsive force field. And that's where it gets interesting, because these two forces are not easily explained in one simple relationship. The relationship between these two forces has never been fully understood. I will tell you point blank, because I happen to know this from my own research. You're looking at the cutting edge of physics where our knowledge ends. This is the last thing that we're able to say, and after that, we can no longer explain it. It's these two forces. So that's the second thing I wanted you to see. All of this is preparatory. You can see that this is a force curve. I want to make this simple for you, so I'm going to show you another diagram now. Look at the innermost curve, and now look at this. The central curve where it dips and then skyrockets up to the vertical line. It's going asymptotic to the vertical line. This is the curved line that begins on the right, and it's asymptotic to the horizontal line. Asymptotic is a term which I trust you understand. But let me show you again. That is the innermost Boschkovich curve. This is taken from Wikipedia, and it describes the force that is holding these light blue protons together in the nucleus, up to 100 of them. The reason why that needs to be explained is because protons repel each other. They each are considered to have an electromagnetic charge. That is what the plus indicates. The proton has this charge. Why is there a proton next to it that appears to be locked with it? That would be helium. If there are three, it's the next element, and this is how the elements are formed. By protons binding against their electromagnetic charge. The electromagnetic charge relationship between two protons, where it inverts from repulsive force, or it's coming in from the right and dipping slowly downward, that is steadily increasing repulsive force, which indicates that the protons are repelling each other. But when the protons get close enough, at about the 1 femtometer range, if you can read that 1 on the lower horizontal line, that's where the curve skyrockets up off the edge of the graph. And that corresponds with the innermost line skyrocketing asymptotically with the vertical line. So this is also an asymptotic curve. And you can see that the line coming in from the right is asymptotic to the horizontal line. Asymptotic, just to be sure that we all know what that word means, and it never hurts to repeat a definition, except it can be tedious. This should not be tedious. Asymptotic is a fundamental relationship between two dimensions. It has to do with Zeno's paradox, and that might fully explain it in your mind right then and there if you have any doubts about what it means. Asymptotic is the relationship between two lines where one of the lines is ordinarily considered to be straight, and the other line has a relationship to it, but it's curved. So it's a relationship of a curved line to a straight line such that they're almost parallel, but they're not parallel, but they also never meet. And that's a paradox called Zeno's paradox. You see two of those on this diagram, and you'll notice they're perpendicular asymptotes. So this indicates there are two forces. This shows the relationship between those two forces. This is a diagram of the cutting edge of mathematical physics. In the mathematical relationship which has been discovered to exist inside of these two particles. They're essentially the same particle in the sense of weight. They weigh almost exactly the same thing. They have the same dimensions. And the difference between the proton and the neutron can now be explained mathematically due to the discovery of a man named Gell-Mann. So these are called quarks, and you can see there are three of them. And that's really the most significant fact. You can see it's a variation of 2 to 1 and 1 to 2. If you look carefully, you'll see that there are two U's in the blue one, but there's only one U in the second one. That is actually an oscillatory relationship. You're looking at a simple harmonic. I'm sure it's been clearly perceived, but it's not being developed. And I know the reason why that critical geometric insight is not being developed. But this goes one step beyond my own research. I cannot claim yet to know the exact definition, mathematical formula, mathematical definition, and everything else that fully explains this up-down quark system. But I can tell you for certain that I can see that Gell-Mann definitely made a significant discovery. It's just quite difficult to explain unless you have a lot of pieces of the puzzle available to you and you're able to put them together in just the right way. Well, really, that's what they're trying to do, and they've encountered some complications. Predictable, actually. So that, I definitely wanted you to see that. Here is a simplified version of the Boschkovich force curve, which, simply to satisfy your curiosity, I'm sure if you've never seen this curve, you would certainly be interested in knowing why there's more than just this curve. In this one, there are quite a few more humps. Each one of these curves describes a balance. The curve itself is not the path of the particle or the position of the particle. At the center, where the vertical and horizontal lines meet, that is a proton. The proton is always at the center. There's no such thing as an electron center to a system. The electron is a self-contained system that has a much different structure than the proton. That's why in all of these diagrams, including this one, the vertical line on the left here is representative of the center of a proton. And the reason you can think of it as all the way across the line, it's really at the 0 point, of course, is where the center of the proton is. The vertical aspect of the graph is not spatial. So you see why this is a very interesting relationship, because the curved line is not the position of the other particle. The position of the other particle is always on that middle horizontal line, because it's a linear relationship between the two particles. A linear spatial separation. It's worth saying that out loud because of what's happening here. The particle only travels, if you think of it as having a velocity, then it would be heading toward the 0 mark, coming in from the right. But it's never on the blue line. It's on the center line going straight for 0. So the blue line represents its relative velocity based on position. Really, whether it's being repelled or attracted. When the blue line is below the median, it means that the particle is being repelled. So that if it had no velocity, then this diagram shows how much repelling force would be on the other proton. This is a proton-proton diagram. Depending on how far away one proton is from another, this diagram will tell you how much force is acting between the two protons. So I did want you to notice that this is the curve of the binding force of two protons. The repelling force decreases dramatically, and where it crosses the median line, there's no repelling force. And if the proton still proceeds from right to left and passes where the blue line is and is now further to the left of the blue line, then it's being attracted, correct? And then you can see the attraction. How would you describe the attraction? It's increasing faster and faster, and it's going to infinity. So this shows that if the proton has sufficient velocity to pass the 1 femtometer maximum repulsive sphere, if it penetrates that sphere within a fraction of a femtometer, it will be under the influence of increasing towards infinity attractive force. However, this diagram does not say that it does go to infinity. In fact, it says something subtly different. For the same reason that the particle can be anywhere off to the right to infinity, that doesn't mean that it can be at infinity. It means that the force relationship proceeds further. It will never become 0. To the same proportion as the attractive force between these two protons. Picture them locking together. Well, they lock together at a certain discrete distance, which is a fraction of a femtometer away from each other, and they're locked together with a space in between them. And after that, it's static. That they are now locked together on that asymptotic line in that relationship between their two force fields. Their force fields essentially interlock. The reason Roger drew this, and this had been his original drawing, but I think this is simpler to look at. This no longer shows the same relationship between two particles for this reason. This shows the relationship not between two protons. This shows the relationship between a proton and an electron. And the valence is reversed so that the dip is no longer representative of the strong binding force in the nucleus where two protons can lock together, and then more and more can lock together up to about 100, at which time it becomes unstable. Another interesting fact. But this is the relationship between a proton, which is at the 0 mark, of course, as before. The proton is always at the center because it makes a center in space. The electron does not. The electron is a much different formation, although they do have strong similarities, and those have to be carefully distinguished. But the reason there's more than one curve now is because the repulsive attractive relationship is inverted, and an electron is naturally attracted to a proton. Since they have opposite electromagnetic charge, the electron speeds straight toward the proton as if to collide with it. Here, the electron, when it's in the same relative position as the proton had been above the trough, it's being maximally attracted, after which suddenly it encounters an increasing, first a loss of attractive force. It decreases quickly, and then it becomes repulsive force, so that as the electron reaches the position C on the horizontal line, it's now being repelled with what approaches an infinite repulsive force. But it never reaches infinity, but it also never reaches zero. And that's the asymptotic curve. Here you saw that the proton has a mechanism inside. That's a harmonic, which will govern the two forces. This is showing that there are two forces, and this is the Boschkovich curve showing the force relationship. This diagram here 100% predicts the Bohr atom. Each one of those separate curves is an electron shell. Each one of those curves represents a spherical shell around the proton. This antedates Bohr's discovery by over a century. This shows the relationship between an electron and a proton in an atomic system, basically the simplex hydrogen atom. Before the atom was discovered, before the electron was discovered, and before the proton was discovered. And this will wrap up our present episode in the value of the number 2, that instead of gravity being a one-force system, there must be a second force, anti-gravity. This diagram proves the existence of anti-gravity as the other force that balances the universe, 100%, according to no less than Emmy Noether, the Nobel Prize winner, and only the second woman to get that prize in physics, for her force symmetry law. This shows the two-force symmetry that replaces our notion of gravity. In the next episode, I'll show you that this is a diagram, directly a diagram, of space-time. You are looking at the true geometry of space-time at the quantum level. If you can credit or penetrate in any way what I just said to any degree, you will not want to miss the next episode. It goes far beyond the grand unification theory that Einstein sought with all of his strength in the last part of his life. This is what he was looking for. And so is all of physics. This is Anagalactic, bringing you the secrets of the universe in this upcoming equinox series, where we're still going to use 2 as our guiding star, so to speak. I will be increasingly introducing you to a new geometry which is simpler than the Greek trigonometry on which all of science is based. This is the breakthrough insight that has been intuited, and I could even point out a recent video that was done. That'll be in the next presentation. I'll get some information for you on that. So you'll see this is actually the solution to all the problems in physics. at the cutting edge. The correct mathematics. Keep looking up at night. This is a good time to be looking at the night sky, although there is a full moon and now it's just begun to wane. Never a good time for astronomers unless you're one of those blessed few, and I happen to be one of them, that just loves looking at the moon. I love looking. That's why I want to get another telescope. I've had two, and I've had two pairs of astronomical binoculars. All of these have been destroyed either by fire or theft. But I'm going to get another telescope, and the reason why? So I can look at the moon. It's just me. I'm sorry, but you know what I mean. I'm not sorry at all. I'm happy. But stellar astronomers are much more blessed than I am, and I know they are, and I'm jealous. But I'm also a galactic astronomer, although not hands-on, because you need photographic equipment. That's $50,000 if you want to be a galactic photographer. $50,000 minimum. That's buy-in for that game. $150,000 is nothing. $500,000 is about what you'd want. But you actually would want your own friggin' multi-billion-dollar dome on the far side of the moon is what you're going to want. Well, we have another lifetime after we're done with this one, and maybe we'll get a chance to achieve some of those dreams with the aliens who will be guiding us, we pray. Otherwise, nothing matters. We're done with the philosophy part, though. I like to remind you, though, this all fits into the big picture of life. Science is not something that's done off in a cage by geeks. A real full-grown man becomes a scientist as a one-to-one correspondence. There's no other way to become a man than to become logical and stay that way. That's what we're blueprinted to be as men. And astronomy takes the place of work. We'll be right back.